So I'm just going to look at this factoring problem. It says factor negative 14x to the 7th plus 66x to the 4th plus 20x. The reason I'm going over this video is because a lot of people might freeze up on a problem like this. Like you see a lot of things happening. Like you see a negative, you see variables with pretty high exponents. But the note you want to make here immediately is the fact that we have this leading negative. So you always want to factor out a leading negative. So factor out the leading negative. So I'm going to factor out a negative. Now, what else am I going to factor out? Because I know I have a leading negative, so I got to take that out. So I'm factoring out leading negative. Now, if the negative wasn't there, if it was positive 14 and then it was like minus 66, I wouldn't need to take it out. But since it's a leading negative, we always want to factor that out. Then next, we want to think about a GCF. And that's going to be, is there a number that goes into 14, 66, and 20? Is there a number that goes into, or can we also take out X in some way? So that's the thing you want to think about. But between 14, 66, and 20, the first number that's jumping out to me is 2 because they're all even. I know 14 is 2 times 7. 7's not going into 20. 7's not going to 66. But I don't need to worry about anything else. So let's take out 2. So I know I'm going to take out negative 2. What else could I take out, though? I have x to the 7th, x to the 4th, and x. Since they all have at least an x, they all have at least one x, I need to take out an x. So I'm going to divide all three of these terms by negative 2x because I'm taking out the leading negative. I'm taking out 2 because they're all even numbers. 2 goes into all three of those numbers. And then I'm taking out x on top of that because I have an x in all three terms. So let's go ahead and do that. Negative 14 divided by negative 2 is positive 7. X to the 7th over x to the 1st. When you are doing division of variables, what you want to do is you want to subtract the exponent. So it's 7 minus 1, which gives us x to the 6th. So 7 x to the 6th. 66 divided by negative 2 is going to be negative 33 x to the 3rd because you have x to the 4th over x to the 1st. 4 minus 1 is 3. So I get x to the 3rd. 20 divided by negative 2 is negative 10. And then over here, x over x, that's just going to be 1. It just cancels out to 1. And if you want to see the math worked out there, x to the 1st over x to the 1st. 1 minus 1 is 0. So you get x to the 0. Anything to the 0 power is 1. Also, if you had like 3 divided by 3, that's just 1. So when you have this x over x, that's just 1. And then there it is. And you could always check your work. Go back and see, is there anything else that I could have factored out here? And the answer here is no. There's nothing else I could have factored out. I have a 7 and a 10. Nothing goes into there. Yeah, I don't think there's anything else that we could possibly do. It doesn't hurt to just like look at these terms here and see if there's some sort of way that you can potentially factor this further. And I'm trying to lead this into here that, wait, I have x to the 6th. That's interesting. Because if I think about this, let's just think about what happens. What happens here? I have x to the 3rd, x to the 3rd. Well, if I multiply x to the 3rd times x to the 3rd, I get x to the 6th. So I potentially could have some factoring here. I could have another type of factoring. And in that middle term, if I were to figure out what this and this were, this would be something times x to the 3rd. So I'd have like blah, 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 x to the 3rd plus blah, 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 x to the 3rd. And then that would give me my middle term of x to the 3rd. There could be something here. There could be. I don't know. I don't know if there's anything. But what I'm noticing right now is that there could be, because I have those first terms working out where I could have x to the 3rd times x to the 3rd. And whenever you're multiplying by the same base, you add the exponent. So you do 3 plus 3 to get x to the 6th. So that's where my mind is right now. I'm thinking about, well, maybe I can set something up. So let's try it. Let's use the AC method. Let's see if there's anything. So I want two numbers that multiply to negative 70 and add up to a negative 33. I don't know. Let's try it out. Let me erase this. So again, I'm doing AC method right now. I'm ignoring this negative 2x because that was my GCF I factored out. And then I have 7 and negative 10. So I multiply those two terms. 7 times negative 10 is negative 70. I think I erased the negative 7 when I was erasing that. And then I want it to add up to negative 33. off the top of my head, 7 and 10 is not going to work. But I'm thinking maybe 35. What would happen there? So if I do 70 divided by 2, that's 35. So 2 times 35. If I mess around with these signs, I could get this to work. Two times negative 35 is negative 70. 2 plus negative 35 is negative 33. It works. I can factor this. So let's go ahead and do that. So I'm going to factor this. So I'm going to bring down this negative 2x. Do not forget about that GCF. And I'm going to rewrite 7x to the 6th. I'm replacing negative 33x to the 3rd with my two factors that worked. So I'm going to write this as plus 2x to the 3rd minus 35x to the 3rd. I thought I got the small eraser. What did I say? Plus 2x to the 3rd minus 35x to the 3rd. And then minus 10. So this is just AC method here. Let's go ahead and factor this further. So I'm going to bring down this negative 2x. Do not forget about that GCF that we factored from the start. So now we have 4 terms, so we're using factor by grouping. So I'm going to group the first 2. I'm going to group the last 2. From the first 2, I can factor out x to the 3rd because I have at least x to the 3rd in common. So I'm going to take out x to the 3rd. That's going to leave me with 7x to the 3rd, not 2. So when we're dividing by the same base, we subtract the exponent. 6 minus 3 is 3. Plus 2, because I divided out x to the 3rd. In the second set of parentheses, we have a leading negative again. So I could take out negative 5. I do not have any x's that I could take out, so I'm just going to take out negative 5. Negative 35 divided by negative 5 is positive 7. X to the 3rd. Negative 10 divided by negative 5 is positive 2. And there it is. I have the same terms there. So I have this negative 2x, so negative 2x. I'm now factoring out that term of 7x to the 3rd plus 2. And I'm left with x to the 3rd minus 5. My goodness, that is a problem there. And I probably don't even need those brackets. Let me just write it out. Negative 2x. 7x to the 3rd plus 2, x to the 3rd minus 5. This is an awesome problem because, and even as I was talking, I was trying to lead it like, hey, we factored out a GCF, we got a weird looking trinomial on the inside, probably can't factor it, move on. Not necessarily. You want to look at the variables with the exponents and see, is there a relationship that can be made here? Just like if you were left with something like x squared, and then this middle term is x, like I'm just making up something, minus 10. Then what the relationship here is x. So when I have these two terms, this is going to be x, this is going to be x, x times x is x squared, and then I multiply this and this, so then I get like 2x plus 3x or something like that, and then that gives me this middle term of 5x. That's the relationship that I was looking at here. I noticed that I had x to the 6th, so then I thought, well, x to the 6th is x to the 3rd times x to the 3rd. This middle term is x to the 3rd. So I have something there, and there it is. And so after we go through all of that crazy fancy footwork, that would be the answer at the end of the tunnel. Yeah, very deceiving. That could be a problem that I would assume a lot of people would get to this point and call it a day and think they did it. But yeah, there's some extra factoring there. Hopefully you enjoy that one.